Do you ever wonder if there's something wrong with your brain? And I'm not talking metaphorically, like physically broken kind of wrong. You may not, but I know mine is. You see, every couple months, a random idea will pop into my brain, and I instantly think I should drop everything. It's only gonna be a couple parts. It'll take a few weeks max. It's not gonna be like those other projects. Well, it's been 3 months, and there's no end in sight. Leading me to ask the ultimate burning question. How on earth did I think this was gonna be simple? Like all projects, this one started with a simple dream: to make my life less of a never-ending hellscape. The source of all my problems is this, my camera slider. If you're not in the know, camera slider does, well, pretty much what it sounds like. It allows you to slide your camera side to side to get smooth motion for video. The only problem is they suck to use, like royally. They take forever to set up, especially to reposition. They only go side to side. They often need 2 stands, and you have to do like a million takes in the hopes that you can get your over-caffeinated hands to stop shaking long enough to get that shot. Oh, good luck. So, goal is simple. Make a better slider, one that can go in any direction, is really fast to reposition and set up, is motorized, maybe even has a 3D head. Oh, and most importantly, it's gotta look bitchin'. Well, not to toot my own horn, but I think I nailed it. At least on the bitchin' part. Now, we're not gonna go into every nook and cranny of how this thing was built, really do more of a general overview and hone in on some of the more interesting concepts and ideas. Like the original idea, the construction is, well, simple. We have the fixed jaw, which is this outer tube thingy. Then we have the movable jaw, which the camera attaches to. Then you have the 3D printed bearing, which allows the outer tube thingy and the inner tube thingy to jive. And then finally, you have the motor housing, which does motor things. Descriptive. Let's start with what I'm calling the movable jaw. Like everything else in this project, it's simple. But actually this time, it is nothing more than a piece of square aluminum tubing with 2 caps welded on the end. Well, there is one hanging jet. It has to be an incredibly, and I mean incredibly precise square tube, both in its squareness as well as parallelism. So it's a perfect candidate to go on the mill, which would make it a total cakewalk. Wasn't, well, a problem. It doesn't actually fit on the mill, at least not completely. Plus, my mill is, well, pretty old, and like a lot of old things, it has a propensity to be a bit saggy. All this jankiness led to a lackluster result. The squareness is good, but parallelism varies between 5 and 10 thou across the entire length. So, like, not what I was going for, but it might work. I don't know. It's gonna have to work because I'm not spending another weekend making a new one. It's just not happening. Now the movable jaw is done, but we need some way to actually attach the camera and other accessories to it quickly and easily. What you're about to witness might be my dumbest idea today. You see, I could have easily achieved this by using simple off-the-shelf parts. But for some inexplicable reason, probably brain damage, I couldn't bring myself to do this. Instead, I spent weeks machining my own custom dovetails and mounting plates. The mounting plates were particularly painful as they're essentially just a zillion 1/4-20 drilled and tapped holes. The dovetail plates, on the other hand, were actually kind of fun. I've always wanted, or at least been looking for an excuse to machine my own dovetails. Although, realistically, I should have made them out of steel and not aluminum. Well, the fun's over though, because next up is anodizing. You see, aluminum by itself is soft like cheese. After just a couple weeks, these parts would be scratched and dinged all to hell. This is why most professional products are typically anodized. Anodizing produces a controlled oxide layer that's incredibly hard, like in some cases almost as hard as tool steel. And according to YouTube, anodizing at home is simple and easy. All you need is a handful of household materials like a bucket of battery acid, some lead sheet, titanium wire, and a little bit of electricity. Well, YouTube lied to me, because anodizing at home is not simple and it is not easy, like at all. My first attempts turned out really weird, producing this bizarre rainbow effect. So this led me to spend at least a month's worth of weekends researching and trying everything I could think of. And all this hard work sorta helped. The parts look decent-ish, but they're still wildly inconsistent. I really had to fight myself not to redo the mediocre ones. Biggest takeaway is surface prep is king. Ideally, the parts should be bead blasted, but I'm moving on. And the thing I'm moving on to is the outer tube. And just like the inner tube, it's also just a piece of square aluminum tubing. And unlike the movable jaw, it doesn't have to be anywhere near as accurate. So, to make it complicated, let's add some unnecessary speed holes. But if I'm being fair, they do serve some function other than making the thing look pretty dope. They provide access to the internal components, they also act as kind of a makeshift handle, and most importantly, they help reduce weight. Because this thing, well, she's a real chonker at nearly 10 pounds. Now, normally on a project, drilling a bunch of big holes wouldn't really be considered interesting. You'd chuck a hole saw into a drill press and just go to town. But as always, there's a problem, and that is I have a deep-seated hatred for hole saws. And anyone who has tried to use one to drill through thicker metal knows my pain. It basically involves listening to this sound for hours on end. So let's mix it up a bit. Let's try our hand at a little bit of trepanning. Essentially, all we need to do is make a custom ground single point cutter and chuck it into the boring head. Now, this is not the fastest technique in the world. We're only taking about 2 to 3 thousandths per revolution here, but what we lose in speed, we more than make up for enjoyability. That's a word, right? Like, no joke, I could spend all day watching this thing slowly peel up metal chips. Although, it wasn't all sunshine. It did take me a few tries to get the cutter geometry rightish, still not sure. And the part did pull out of the vise on a handful of occasions. That said though, I'm already looking for excuses to use this technique on other projects. The last major thing to knock out on the fixed jaw is the finish. The part is way too big and I'm way too scarred to do anodizing at home. So let's do some powder coat, which is not without risk. This is a brand new color that I have never used before, and well, I certainly can't be bothered to do a test sample. So I legit didn't know if it was gonna turn out terrible or beautiful. Well, luckily rolling those dice totally worked out, because it turned out fantastic. Like the deep blue and the metallic sheen when the light hits it is just bombastic, and might be my new favorite powder coat color. The next part is hands down my most unique to date. Honestly, it might be the first of its kind in existence. Maybe. You see, we need some sort of low friction interface layer to go between the movable and the fixed jaw to allow it to move. So it needs to be tight tolerance, low profile, and have an incredibly low coefficient of friction. The obvious choice, a bearing. The problem is no one actually makes a square linear bearing. They make round linear bearings, they make linear rails, They make adjustable square bushings, but no one, and I mean nobody, makes a square linear bearing. In fact, I don't know if anyone's ever made one. So when no one makes what you need, path forward's obvious. In this case, we're just gonna rip off the design of the linear rails, which use a series of recirculating ball bearing tracks, typically in an injection molded housing. We're gonna replace the injection molding with 3D printing though. And this time, my brain was actually working, because I was like, I should do some tests first. And I learned 2 things from these tests. Number 1, this might actually work. Like, it might actually work. And number 2, FDM 3D printing is not gonna cut the mustard. It is simply not accurate enough to be able to produce parts repeatably with 2 to 3 thou clearance. I would print 2 parts, same part. One would come out perfect, smooth as a whistle. The other one would jam up and grind instantly. So we gotta pivot, and we're gonna pivot to resin 3D printing. Big leap. Resin printing is much more precise than FDM, and so basically I'm just buying my way out of this problem. Now, it didn't solve everything though. One of those being the sheer size that the bearing needs to be. At nearly 7 inches, this bearing requires over 2,000 ball bearings, which by itself wouldn't really be a problem. The problem is each ball bearing needs to be loaded by hand, individually, one at a time. And even that actually wouldn't be that much of a problem. It takes about 2 hours to load one bearing. No problem, one and done, be ready for lunch. In reality, I'm like half a dozen attempts in and still loading ball bearings. Resin printing is super weird, like weirder even than me. The printing process itself is incredibly precise, but the resin is not, like, at all. It goes through these weird phases of expanding and contracting over many weeks. I would print a part, test fit it, tolerances would be spot on. Come back a week later, wouldn't fit at all. Like, what? What? What are you doing to me? This made dialing in the bearing fit incredibly painful and incredibly time consuming. It does eventually stabilize after like a month, and the movement is only on the scale of like 5 to 10 thou. But that was more than enough to make this easily the worst part of the whole build. The final 4 to make this whole shebang work is the motor housing, which at first blush looks wildly complex, but really is nothing more than some plastic, a motor, fan, knobs, switches, and a custom PCB to tie it all together. The big problem is I have no idea what I'm doing. This is both my first custom PCB design as well as my first Arduino coding project. Yet I was still genuinely surprised when I made some pretty major mistakes. The biggest one being on my PCB, I didn't connect my ground port to the ground layer, which resulted in horrific levels of electrical noise coming from the housing. I also failed to understand how capacitors work and managed to send 5 volts to a couple pins that needed ground. In fact, I did that not only on the first version of the PCB, but on the second one too. Eventually it all worked out, and all that's left is to shove my fingers into this tiny little housing and plug in all these wires. Luckily my hands are kind of dainty. Next, we give it some juice and let it go for a test spin. Program-wise, we have 3 different modes. Basic Beagle is, well, basic. It allows you to go forward and backwards. Endless Doodle goes forward and backwards, but a set distance and in an endless loop. Like that one. And then the third mode, Fancy Poodle, is based off a series of waypoints you set and is really intended to be paired with the DJI gimbal tracking mode. I've killed 4 to 5 months worth of weekends. All the parts are made, and it's time to find out if this thing actually is gonna work the way I think it will. right? It's ridiculous. It is ridiculous. But it does actually work kind of good. Let's show you. Let's give her some power. Takes no time at all. Let's yank this off. Over here, we got the camera all ready to go. Lock her in. And she's off to the races. Look at it. Look at it. It's not that fast, okay? It's not that fast. We can go faster. We can. Yeah, let's crank her up. Yeah. It's a little noisier. I don't know if you can hear that. You probably can't. Forward, back, left, right. Let's slow it down. I like to go slow. I like it. Nice and slow. But setup's not slow. Here. Stick it side to side. Oh, let's do a push. Let's push in real quick. Yeah, right. Oh, we can get real weird. Going down. Oh yeah. I love it. Yeah, let's go slow. And let's really mix it up. Ooh, careful now. Getting a little too excited. All right. Ooh, don't do that. There we go. Oh, look at it go. Yes. I don't know why you went out this shot, but like, you can do it. You can totally do it. If you really want to get weird, if you really want to get crazy, shoulder mounted rig. Look at it. This thing, it's not that bad. It's kind of front heavy, I'll give you that. But, you know, if you need robotic verite coverage, oh, so smooth. Yeah, very, I'm so out of focus. Oh. Who needs an FX9 when you got this? Teardown's just as fast. Battery off. Camera off. Back to normal shooting. So yeah, not half bad. It like totally works and has opened all sorts of new fancy shot possibilities, like the opening to this video. Now, despite my over-exuberant enthusiasm, there are plenty of things I would change about this build if I did it again. And there's already a bunch of fancy attachments and new features I want to add. The entire build is modular, so it'll be simple to redesign it and change it out in the future. See, I have managed to learn something over all these years. Your first idea, it's never going to be the right idea, no matter how desperately you want it to be. But for now, I'm just gonna let it ride, see where it takes me. Will I ever come back and fix the problems? Maybe. Denial, back in action. Let's go!